I'm Kelvin. I'm a software engineer, principal software engineer at sort of a mid-sized tech company. I've been doing this for over 10 years now, and coding challenges, I'm not an expert at them, but I've also got good enough at them to pass big tech company interviews with them. So tonight I'm going to do what's considered an easy problem on Leetcode.com. That's Leetcode.com. That's a website where you can practice these problems. I'm going to do a problem called valid parentheses. It's an easy problem. I don't have Leetcode Pros, but if you get Leetcode Pro, you can see what companies actually asked this problem, what real companies have actually asked this problem. But I know that Leetcode at least considers it an easy. Easy is relative. I think when you get familiar with these type of problems, you may also agree that this is an easy. But if you've never done these problems before, even if you're an experienced programmer, you might have some problems with this because this type of coding challenge, data structures and algorithms doesn't necessarily come easy if it's not something that you're practicing or it's something that you're recently familiar with from doing like a computer science degree or whatever. So anyway, I'm gonna go ahead and jump into it. It's called valid parentheses and parentheses, I guess, and it goes as such: given a string s containing just the characters, you see the characters here. Open. Wait, what is this called? Open. Is this open parentheses? Yeah, open parentheses, close parentheses, open bracket, close bracket, a curly bracket, close curly bracket, and open bracket and close bracket. So there, these are open and close parentheses, open and close curly bracket, and then open and close regular bracket. From this string containing these characters, determine if that input string is valid. Is it a valid parentheses? An input string is valid if open brackets must be closed by the same type of brackets. Open brackets must be closed in the correct order. Every closed bracket has a corresponding open bracket of the same type. So these will make sense when you look at example 1, 2, 3, 4, and 5. So of course here, open and close bracket, true. The output is true. So for the input, the string is S. Inside of the string, we have an open and close parentheses, and the output is true. And example 2, we have open and close parentheses, open and close bracket, open and close curly bracket. Because each of these is properly opened and closed, then it's also an output of true. Now to a bad example, you have an open parentheses and a closed bracket. That's not a valid case because it fails. Open brackets must be closed by the same type of brackets. Every closed bracket must have a corresponding open bracket for the same type, and they must be closed in the correct order. This one's not actually failing, but the 1 and 3 are failing, and so that's why this output should be false. So my program that I write should take S, this string, as a parameter, as an input, and then it should output false for that case. And so here's another case. You open up a parentheses, then you open up a bracket, then you close that bracket in the right order, because when you open something, you need to close it before you close the one that happened before. It needs to be, basically, it doesn't need to mirror each other, but you just need to make sure that you properly close the brackets when you open them. And so in this one down here, you see that you open a bracket, and then you open a parentheses, and then you open a bracket, and then you close the parentheses in the wrong order. So you can't close a parentheses before you close this bracket. You have to close out the thing that you open before you close, the other thing that you open after it. So you need to close the things in the right order. So like, as you can see here, when you open this one, you close it immediately. So you basically at a blank state, and you just do that same thing. On this one, you open this one, and then you open a different type before you close the first one. Then you close that one first, and then you close the second first, the next one first. So it's kind of like common sense. I mean, this is how we use it use these things in the English language. You wouldn't just like open a bracket and then close it with the curly bracket or something like that. You just wouldn't do that in the English language. So you got to just kind of think about it like that. But you need to write a program to be able to accept that input and then return the output as true. So somebody said, what website would you recommend using to learn how to code? There's so many resources now. I mean, you can use AI, you can use YouTube. I recommend Free Code Camp is a good place, like Udemy courses. There's so many places, but just like DM me and we can talk about maybe like your learning style, because it really just depends on your learning style. Now there's so many great options. It's really not even just one thing. But anyway, I'm going to keep going. So down here are constraints. So sometimes you're given these constraints in these type of interviews. Sometimes you aren't. Sometimes you can ask for them. But typically they'll have them in the problem definition. So the constraints is saying that the length of s dot length, that's the length of the input string. So in this case is this, is always going to be at least 1. So I don't have to worry about the case when it's going to be like 0 or like nothing in the string. It'll always be at least one thing in there. And it's less than or equal to the length. 1 is less than or equal to the length, which is less than or equal to 10 to the 4th power, which is pretty high, but it's not a number that would be outside of the bounds of the data structure or the data type that I'm going to be using in the programming language that I'm going to be using. And S consists of parentheses only. And so S will always contain these characters. I don't have to worry about like some kind of like other weird character getting in here that I need to process. I can just make my program just only process this because these are the constraints of my input. So I can, in this case, the constraints, in these type of problems, you can trust the constraints. You can write your program and trust. You don't have to validate that your constraints are true. You can trust those as guaranteed truths. Now, anything that isn't in the constraints, you need to ask the interview about it, or you just need to program against it. Like if it didn't say this line, I may need to program and just make sure that I don't have any invalid characters in my program, and I probably just return false if I did have some kind of character that wasn't one of these parenthesis types. So anyway, that's the problem definition. And typically in the interview, you will read over that and you would try to understand it. And so I understand it as, I just need to process this string somehow with an algorithm with some code, and I need to determine whether or not the brackets are being closed properly. So when I open a bracket, I need to make sure before I close another bracket that I close that same bracket. So if that makes sense, I hope that makes sense. So the bad example here, when I open this bracket, I need to make sure that the next closing bracket I see is the closing one for this. And so so I need to make sure the closing bracket I see is the next closing bracket for this. So I put this in there, and I'm my bad. The next one the last one I see, the last open bracket I see, I need to make sure I close the last open bracket that I see. That's very important. And that's why I would probably get confused on this, because it's kind of hard to think about, like, what is actually happening in this problem? How can you validate it? And I think the trick here is that you can open as many brackets as you want, but as soon as you see a closing bracket, you need to check the last open bracket you saw, parentheses that you saw, and make sure it's of the same type. That's basically what you have to do in this problem to make sure as you're traversing through this string that is right. So like in this case, I open this one, and then as soon as I see a closing one, the last one I opened was the same type, so I'm good. Here, I open this up. As soon as I see a closing one, I know that these are the same. Then I open this up. As soon as I see a closed one, the last one I opened was the same. So that's how it works with that. This one, I open this one up. Then I open this one up. So the last one I seen was actually a bracket. Then when I close a bracket, the last one I seen was a bracket. So I'm good right here. Then I see another closing. The last one I actually seen before this one was the closing bracket. So I actually like kind of cancel these ones out once I'm ready. So that's how the problem works. Now, how you would do this in code, I don't know. I've done this one before, so at this point, I don't know if it's an intuitive solution. Y'all can let me know if you think it is, how you would solve this. And I've seen some people have an idea in the comments of how they would actually solve this. I don't know if it would be intuitive, but I know that I basically need to keep track somehow of I need to keep track of all the brackets that open up, and then I need to make sure that I'm closing them in the proper order. And there is a particular data structure you can use to make that easier. So you could put them in an array. In a sense, you could put them in an array, and you could or you could put them in a map or something. You could use different data structures, or you could just create variables to try to keep track of what you opened up already. But there is a particular data structure, which is sort of a form of an array, called a stack, that you can use that can make this solving this problem easier. So how I'm thinking about this, and this is what you would do in the interview. You want to explain this to, the interviewer themselves. But how I'm thinking about this is that every time I open, I have an open, what they call it, parentheses, I'm going to put it into a stack. And I'm going to basically stack those parentheses on top of each other. The parentheses on the top of the stack is the last one that I opened up. That's very important, because as soon as I see a closed parentheses, then I need to check the top one, the last one I opened up, the top one on the stack. I need to check that it is the same type. So it's either one of these two, or one of these two. So I need to check that it's the same type. If it's the same type, I basically can kind of cancel it out as that one has been closed. That parentheses has been closed properly. I don't need to focus on it anymore. And I actually at that point can pop it off of the stack, which means remove the top thing off of the stack. So I can just take it away from the stack. And then when I find my next closing thing, I can check the top of the stack, and I'll have the last one and make sure that it's closed in the right order. And by building this stack in order, when I'm checking it in reverse, I'm actually checking it in the proper order and making sure that I close the parentheses in the proper order. So if I ever come to a point where the closing parentheses is not the same type as the opening one, then I know that this is not a valid parentheses, and I should just exit out. So here in this case, for example, I would traverse through this string, basically looking at each item one by one. That's what that means. I will put this open. Every time I see an open one, I will put it in the stack. So I see this open one, I'm going to put it inside the stack. And then I see another open one, I'm going to put it inside the stack too. So now I have a stack of parentheses and then a bracket. I'm just calling this parentheses. I don't even know what you would call this normally, but and then the first time I see a closing one, I'm going to check the top of the stack, and I'm going to say, what do I have at the top of the stack? Well, I have this bracket at the top of the stack. This is not the proper closing symbol for what I have at the top of the stack, which is a bracket. So I know this output should be false. In this case, I'm actually going to put these first two in the stack and have the bracket on top. But the first thing I'm going to actually see closing wise is a bracket, which does match what's on top of the stack. I'm going to pop this off of the stack, and now the stack is only going to have this open parentheses. And then I'll be here in my traversal. I'll have another closing thing that I can check the top of the stack, which is this. And these two on both sides do actually, they're valid closures or whatever. And so by checking that, then I know that I can pop that off the stack. And basically, if I get to the end and I don't have anything left on the stack, then I know that I've closed all. Since the stack was consisting of open parentheses, then if the stack is empty at the end, then I know I can return true, because I have closed all my open and closed parentheses. I basically closed all of them. So I hope that makes sense. It's so hard to explain. This one actually is harder than I thought to explain. The interviewer would understand it, so it kind of makes it easier. But like trying to explain it in a way that makes sense in layman terms, that somebody has never done these problems before, or is like very early in their coding journey, it's kind of tough. So I'm not gonna stick on that too much longer. That's what you would do. You would explain it, explain your thought process and your approach to the interviewer. You probably wouldn't take that long to do it for an easy problem. You probably want to do it in like less than 3 or 4 minutes. But I'm trying to, explain my thoughts and try to help people here. So I'm taking a little bit longer. But you wouldn't want to take that long probably in a regular scenario, of course. But anyway, yeah, I would explain that to him and I would ask them, hey, do you think that's a good idea? That should I proceed with that approach? And if they say yes, then I would proceed to start writing some code. If they, in that, you want to ask them, because in that case, they may actually help you. They may say, hey, man, you're way off track. They may say, why don't you think about this? Or your solution is good, but how do you handle this? And they may try to lead you. You give them an opportunity by asking to help you if they're going to help you. They may not help you, but you at least open the door for them to help you. They're definitely not going to help you as much, or you're not going to give them a good enough chance if you just jump straight into the code. So best practice in these type of interviews is you want to read the problem, understand it, ask clarifying questions, ask for any kind of constraints, verify, talk through your solution, ask the interviewer if it sounds good, and then continue. Sometimes they just say, hey, code it out and see. You have to take their lead, but you want to have constant communication with them, because you want to give that positive signal that you know how to take feedback, that you know how to ask questions. Like that's part of the interview too, in addition to getting the answer right. And sometimes some interviews don't even care if you get the answer right. So yeah. Dr. Insano, what's up, man? I used to work with him. Yeah, the stream's working. Yeah, I took your advice, man. My stream had it was like something with the bit rate or something on Twitch, and my stream was messing up on Twitch. But now it's working properly since you told me like whatever you said was like exactly what I needed to do. So appreciate it. Yeah, and I hope you're doing all right, man. Yeah, anyway, so I think after doing all that, yeah, just jump into the code, and hopefully I can do good on this. We'll see how it goes. Oh, I hadn't even been checking on Instagram. Looks like no comments or nothing on there. Okay, cool. All right, so yeah, I'm gonna go ahead and jump into the code. What I do want to do is put this thing on the screen at the top. It's kind of small, but at least it's on there, so people that jump in later, they can see, what problem I'm doing. So this on Leetcode.com, I'm gonna pull this down so you can see. But on Leetcode.com, they give you a coding area where you can try the problem out, try to code it out. They give a stub for the problem and your desired language. You can switch to different languages. And I know for some people that y'all have already seen all this stuff, but some people really, like literally in the questions on TikTok, some people literally have never used this before. So I'm just doing a little bit of explaining. I'm going to use JavaScript. I know a lot of people want to use Python. JavaScript is my language of choice for coding interviews, and it's also what I'm using most day to day in my day job. So I'm going to stick with doing interviews in this thing that I'm like actually would potentially be interviewing for. Some people decide to use Python anyway, even though they're going for JavaScript jobs. That's just not my approach. But Python is amazing. It's the most like popular language on GitHub right now. Just dethroned JavaScript like last year, I think. So both of them are great language. If you can read Python, you can read JavaScript. So please don't worry if I just because I don't do this in Python, because I always get that comment like, why don't you use Python? Just like, it's okay, man. You can read it. Like you can be more agnostic and learn how to read multiple languages, especially multiple similar like dynamically typed languages that are, not very verbose like JavaScript and Python. They're, you can read both pretty easily. So anyway, let's do it. Let's do it in JavaScript. And the first thing I'm going to do is change this to const, just because in JavaScript, it's like best practice not to use var in this case when you have, variable or function that you're declaring that you don't want it to be changed ever. that's a constant. So, you know, it's better just to change it to that so that it doesn't get like hoisted or get changed and cause like inconsistencies in your program. In this case, it's like pretty isolated. It's Leetcode, you know, but still best practice because somebody will come on here and mention that, or it has happened before. So anyway, yeah, so now we're in the code part. Is valid. S is what's being passed in. So S over here, you have to think about it like any of these can be passed in to that S variable within these constraints. That's how you think about it when you're doing this, or when you're just programming in general. If you just kind of have to start doing this, you have to learn like the basics of program. You can't just be like, just start these to teach you to program. It's not a good place to learn how to code. It's more of a place to learn how to practice for coding interviews, or just maybe tighten up your skills or something like that. But S can be any one of those things within the constraints. And then is valid, I need to, at the end, I need to return either true or false, whether it's a valid parentheses. So I'm going to just leave that there. This isn't right code, but I'm going to leave that there. Just know that at the end, I need to return true or false. So what did I say I was going to do in my solution? So I did say I was going to create a stack. In JavaScript, you can actually just use an array as a stack, because it has all the functionality, like built-in functions, in order to use an array as in a stack. In this language and other program languages, you might have to actually use a different data structure, but in JavaScript, you can just use an array. So I'm going to. The next thing I said I was going to do, I'm actually going to look through every letter, every character that I have inside of this string. So how I do that, you can create a loop. And this is just something you just learn as you learn the program. Most of y'all probably know this. I++. So what this does is basically just loop through the string S. You know, it loops an index through the string S and just increments that index. So in a zero-based index in language like JavaScript, you start at 0, you run this loop until it got up to the length -1, since it's a zero-based index, and then every iteration you would just iterate the index. And then how you access the character at that index inside the string S is just using these brackets. So this is just for people that just haven't programmed, but maybe everybody on this that's watching has before. So maybe it's just overkill, but anyway, that's how you do it. So this would be like, I could call this like char or something like that. And so that gives me the character. Basically, this loops through the string and gives me every character in that string. And I'm going to run this code inside of here for every character in this string. So, and that character could be open bracket, close bracket, whatever the case is. So the first thing I want to check is, like I said, if I have an open bracket, I want to push that into the stack. I want to make a stack with all my open brackets. So the first condition I'm going to say is if character is equal to this type of bracket, or is equal to curly bracket, or is equal to the square bracket. Yeah, curly bracket and square bracket is what they call. I couldn't remember the name. If that's the case, then I actually just want to take my stack and use the push function and push that character into the stack. So since my constraints say that S can only be one of these characters, like it can only be one of these, then if my first if conditional checked if it was any of the open ones, then in this, if I do an else here, then that means character is either it's got to be one of the closed ones, if that makes sense. So it's either this one, I'm screwing this all up, or this one, or this one. And I never learned how to type these special characters. That's why I'm looking at the keyboard. But anyway, yeah, so it's in this condition, it's one of the closing ones. And remember what I said, when I find a closing one, I actually need to check the top of the stack to see if the closing one equals the right type. That is a proper closing character to the last open one that I found. So the top of the stack will have the last open. So I can say, let's create a variable called last open parentheses. I guess I can say something like that. And then I can take the stack, and I actually can call a function called pop. That'll pop the thing that's on the top of the stack. Actually, it'll pop the end of the array, but if you're using it as a stack, it'll pop the last thing off the stack and put it into this variable, and it'll come out of the actual stack, which is good in this case. So last open parentheses, I need to make sure that the current closed character, since it's in this case, so it's a closed one, and this should be, yeah, else it's a closed one. So I need to make sure that, let me see. So yeah, if this is the last open parentheses, I need to make sure that, I'm trying to figure out a way to do this without having to write a bunch of crazy code, but yeah, it's really just complicated. So you just have to, I want to actually make this smaller. Like, I want to say, yeah, well, I'm gonna leave it like this. If last open parentheses equals, so I have to check what each one is actually. So if last open parentheses equal this, and the current character equals the closed one, and so I'm actually gonna do this like 3 times. And you're gonna see what I'm doing soon, I hope. Do it one more time down here like that. Just like this. Yeah, so I'm basically saying if last, I'm gonna do all 3 of my types, and I'm just gonna make sure that I get the proper closing one for the proper open, if that makes sense. It's kind of weird to explain, but so basically what I want to do is I want to check my last open. Remember I said the last open one needs to be the same type as the current char, the current close, because I got in here, so it's char is either one of these closing ones. I need to make sure that if the closing one is this one, the last open one needs to be the proper open one to it, and for the square bracket and for the curly bracket. So I just need to make sure that one of these things is true. Either these equal, or these equal, or these equal. If those 3 equal, then I'm good. If they don't equal, then I actually want to just return false out of my whole program. If I come to a point where these don't equal, then I want to exit out of my whole program at that point. So I actually probably could reverse this and say, like I could say if this doesn't equal, like if this is not true, and this is not true, and this is not true, then return false. Because if all 3 of them don't happen, you just put ands in between here actually instead of ors. So I can reverse this to clean up my logic. I can return false. And so since I already popped the stack here, this actually takes the item out of the stack and puts it in here. That's kind of more confusing part. I probably could rewrite this and like do this pop later, but it's actually just clean to just go ahead and pop it out of the stack right here. So what I mean by pop it out of the stack is this not only sets this equal to the last thing in the stack, it also like takes it out of the stack itself and sets it equal to it, if that makes sense. So it gets rid of it out of there either way. So even if I return false, it still got rid of it. But if I don't, if one of these things is equal, I won't go into here, and I'll just go back to the top, and I'll keep looping, and I'll just keep on looping. If I never hit this case, I'll actually get down here. And down here, what I want to actually check is if the stack length is equal to 0. So if the stack length is equal to 0, that means I've popped off every open one I put into the stack here. I've popped it off, and I didn't return false at any point. I didn't have any unequal pairs. Then by the time I get down here, the stack will be empty, and that's how I know that I have a valid parentheses. So I hope that makes sense. I know it might be a little confusing, but I hope that makes sense. Yeah, it's a little bit confusing, but it may make sense to most people. Y'all let me know in the comments if it's making sense or if it's a little bit confusing. But hopefully I'm making a lot of sense, or making some sense. And this is something that, will be helpful to you to at least come back to, or try to do the problem yourself. So at this point, if I get to this point in the interview, I'll probably want to kind of look over my code and make sure that it's working the way that I think it is. Look for bugs before I even try to run it or do anything. I want to talk through and look through what I've done so far. So I basically created a stack, type const, which I can mutate this even if it's const, as long as I don't reassign it in JavaScript. And I'm going to do a loop starting at 0, and this will change. So I'm going to make that be let I is less than the length. Yeah, as long as it's less than the length, it's good. Then I++. The char is the index I into S. That gives you the char. I won't be changing this, so I made it a const. If character is one of the open ones, those are good. It's all three of the open ones. Then push it. If not, then it's got to be one of these closing ones. So I wrote a comment there to say what that is, instead of, because it's just an else. So then I make a new variable called last open parentheses, and I pop off the stack to get my last open one, because the only ones I'm putting in there is open ones. So that'll give me my last open one by popping the stack. Then I check if and I probably can just do if if this is not equal, or is it just one? I can't remember. If this is not equal to that, and this is not equal to that, and this is not equal to that, yeah, return false. I think I can do that. Yeah, if this is not equal, oh no, I don't want to do that. I actually want to just keep it like I got it, because I got these two things here. So I basically want to say if this is not true, and this is not true, and this is not true, then I want to return false, because I didn't find any pairs. One of these needs to be true. I need to find a pair. So the char can only be one of these, and it has this last parentheses has to be one of these matching ones with it. If it's not, then I return false. So I think that's right. And then here, stack length equals 0. That'll return true or false. If I have like an input that has like some weird extra characters on the end, or it has some too many closings or too many openings. This would be the case if it had too many openings. I put too much in its stack and I didn't have enough closings to close off them. Like if I had a bunch of opening ones and just one like closing one, I would still have stuff left in this stack. It wouldn't be 0, and I would return false, even if I made it through this whole loop. So yeah, this looks good to me. So what happened in the interview, some interviewers let you run the code in editor, like they run in some sort of program, like they let you actually run the code live. And then some don't have anything for you to run the code in. Like they just want you, like you might be doing this in a notepad, you might be doing this in a Word document, and they want you to trace line by line through the code and prove to them that it works. I don't want to do that. I'm just gonna run it, because I do that and it's just kind of boring. Like, and nobody likes to watch me just trace through code. If somebody wants me to do that, you can comment, but I doubt it. Like, I don't think anybody wants to watch me do that. So I'm just going to run the code and see if it's right. and then then I'm going to talk about it. But no, the one thing I did miss is you would need to talk about big old complexity here. So you would need to talk about what that is. You would need to talk about the time and space complexity of your solution. How does your solution scale as far as time and space in reference to the size of the input? And so the size of the input is important to find out. And so our input is S. And so what is the size of our input? Sometimes you can use the constraints to find it, to give you a clue. But in this case, it's how many characters do I have in S? What is its length? And so that is the size of my input. That input can change. It can grow. It can be one thing, like here. It can be up to 10 to the fourth power. But it could be worse than that. And this is this problem, but another problem could be worse than that. And so when you're talking about time and space complexity, you have to think of how does your algorithm perform when this number is really, really large? Does it perform linearly? Does it just process the data as it comes and it doesn't get any worse? Does it perform worse as the number grows large, as the length grows larger? Does it perform exponentially worse or even worse than that? That's what time complexity and space complexity is trying to figure out. So time complexity is how many operations your algorithm is doing in relation to the size of the input. Space complexity is how much space are you using in relation to the size of the input. So time complexity, in this case, my size of my input is length. The operations that I'm doing in reference to the size of the input is what I need to measure as I'm looking through this algorithm. So I already see a big clue here with this S times length, or this S dot length. I'm doing this many loops. However long this is how many times this loops. If I have a string that's 20, it's going to loop 20 times. If I have a string that's 2, it's going to loop 2 times. If I have a string that's 200 characters, it's going to loop 200 characters. This always runs one time, no matter how large S is. But this is going to multiply how much all this stuff in here runs. And so this is actually the most important part to look at in this algorithm. Now I can look in here to see if anything else is tied to the size of the input, but nothing in here is tied to the size of the input. It's just this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, whatever. 12 operate. Well, it's probably not 12 because some of these are just brackets, but it's this 10 operations that are happening here. That's actually not, it's actually constant. It's a constant and it's not tied to the size of the input, how many things I have here. This is what's tied to the size of the input. And that's what holds the most weight as far as big O notation. So let's call the size of our input N. So let's call N, let's say N equals S dot length. Let's just give it a variable name. In big O notation, N is commonly used as the variable name as the size of your input. So what this actually is called is big O of N, because for every single N that I have, the length of the string, I'm doing that many operations. All these operations reduce, they're constant operations, they reduce down. This is a constant operation, it reduces down. This is a constant operation, it reduces down. Big O notation is hard to explain. I really would have to do a whole nother session on it. But hopefully this is helpful. And somebody asked on Instagram, are you recording these? What's up, Madison Avenue? Yeah, I am recording these. So you can watch them later. You can go on YouTube and watch them. The whole thing will be on YouTube for sure. And what I'm saying is that this is constant operation. These are constant operations. This is not a constant operation. So this is weighing the heaviest in the algorithm. So it's actually and this is running as many times as I have. So it's just N. So what this is actually called is, like you said, Madison Avenue is linear. So it's big O of N is what it's called in big O notation, or otherwise known as linear time complexity. So let's say, for instance, if I had this another loop nested inside of here. I don't know why I copied that. But let's say, for instance, I had another loop nested inside of here, like that or something like that. then this actually will be n, but then for every n, I'm actually running another n again with this inner loop, so it would be n times n. And so in that case, it would be big O of n squared. So that kind of gives you just a sense of like, how the time complexity can change without going, doing a whole nother problem to try to show that. So also there's space complexity. So space complexity is how much additional data structure you're using to your input in order to complete the problem. Like, what is your algorithm? How much additional memory is it using? So like I said, some of these constant operations, if it's just setting a variable like char, it's just constant. It doesn't tie to the size of our input. What's tying to the size of our input is this stack. If this in big O notation works off worst case. So let's think of worst case. If this was all these open type, like it could be a case where all of them are just open, then I would actually fill that stack up with the length of S. I would actually fill this stack up completely. So I would actually be creating additional data object in addition to my source, to my input. I'd be creating additional one that can grow to the size of n, worst case. So that actually makes, and I don't see anything else in here besides that stack that's directly tied to the size of my input. So yeah, I don't think anything, this is just calling the length, which is a constant operation, constant memory. Nothing else is doing it. So this is actually also big O of n, or linear space complexity. You have to explain that to the interviewer. That's why I went through that. Like, if you get through the problem, get it right, and you don't explain that to the interviewer, you actually could fail the interview possibly, because that's one of the purposes. But one of the purposes behind Google originally creating these style of interviews and these style of questions is because they deal with massive scale. They deal with problems where the input sizes of whatever their data they're trying to process can be insanely large. Like, they deal with the biggest scales in the world as far as they're being one of the biggest tech companies and most groundbreaking tech companies in the world, of course. So, these large tech companies ask these questions because they need to know if you can write algorithms and recognize algorithms that can perform and not perform bad based on scale. So big O of n is actually, or linear, is actually considered a pretty good algorithm. It linearly runs with the size of the input. It doesn't change. It doesn't run worse when the size of the input gets worse. So like, you think about a computer, you try to run too many programs on it, it actually performs worse than it does if you just run a few programs. You run a few programs on it, you run 2 programs versus 4, the computer pretty much runs the same. But then if you try to run 1,000 programs at the same time, the computer starts running really slow. And so that's what like a big O of n squared or a big O of n cubed or, even worse algorithm can be running. Like, it could actually get worse as you add more data into it. And that's what these big tech companies want to try to prevent with these algorithms. You could write one bad algorithm and cause a company cost of, millions of dollars of cost and using expensive resources. So this problem is trivial. You're not using any resources. It seems like a stupid problem. But when you take that to a job and you're actually accessing databases, you're using API credits, you're doing some sort of expensive operation inside of this code, if it's not optimized, then there's potential that you could be wastefully using space or CPU, space, which is RAM on a server, RAM on a computer, or CPU trying to do all those operations. So that, and they have to spin up more servers, horizontally scale or vertically scale, to meet the demand of what you're doing. And it's all needless if you could have wrote the algorithm better. So that's why they ask these questions. A lot of people say these questions are stupid. They have no purpose. I still think they're stupid, but they got a purpose too. So both two things can be true. So anyway, that's kind of just giving a little bit of just trying to give it a little bit of context. But anyway, thanks Madison Avenue. Say loves the content. Always good seeing us in areas unexpected. For sure, man. I'm just trying to get on here and just, teach people some stuff. Hopefully people are learning some stuff and just share my knowledge. And this also helps me too. Like, I got to stay practiced on these type of problems, at least in the foreseeable future. So that's why I'm on here doing these. So Appreciate that comment. Somebody said, what are you working on? I'm doing a coding challenge on Leetcode. Somebody said use a hash map. Yeah, you can't really use a hash map. So you could, a frequency map is going to be hard because you need to keep the order. That's why a stack is important data structure to use here, because you're trying to close the brackets in a certain order. So you can't just, I think some people were coming on and saying, like on TikTok, a lot of comments were saying use a map. And what they were saying is that what I think they're getting at is you would take everything in here and store it in a frequency map, and then just make sure that you got the same frequency for all the opens and the same frequency for all the closed characters. And that would make sure you had enough open and close. That would close out, that would probably say, yeah, every closed bracket has a corresponding open bracket at the same time. That would solve number 3, but it wouldn't solve number 2, that they're closed in the right order. Like it wouldn't, because this one has equal open and closing brackets, but it's not valid. It's opening and closing in the wrong order. It's closing in the wrong order, I mean. So that just using a frequency map actually wouldn't solve this. You got to use a stack, or you got to use something. Even if you use a frequency map, then you need to use some other map to keep the order, which just makes your problem way too complicated. You could have just used a stack. So yeah, I hope that makes sense for everybody that kind of like was saying use a hash map or use a frequency map or whatever. Saying the same thing, but yeah, I think that's why it would be not good to do that, because you're kind of you're either running yourself down a hole that's not going to work, or you're making the answer way too complicated than it needs to be. And interviewers going to want you to do an easy level problem really fast. So you don't want to overcomplicate it in any kind of way. So anyway, I'm going to run this. So Leetcode, you can't see it, but it's a play button up here. Leetcode lets you run the code against the test cases that are over those 5 test cases I showed you earlier. And you can see if your code actually runs up to scuff with that. So it looks like I got some kind of issue. Oh, I left this. This is supposed to be a comment up here. It's trying to run that code. So that was just something stupid. I left it in there. So yeah, I got all these right. And I actually just erased. Well, yeah, I'll leave this here because you need to know what N is in big O. But yeah, so all these right. So these are basically the test cases from over here. Example 1 through 5. They put it down here. Oops. They put it down here as the 5 test cases here. So basically, when you feed this into it, my program returns true. When you feed this into it, my program returns true properly. You feed this into it, my program returns false. You feed this into it, returns true. And then of course this one is wrong. You feed that into it, returns false. So my program is working well, at least for those 5 test cases. I got the time complexity right. At an interview, I'd probably be good to go to the next problem. They probably ask another problem if it's easy. Maybe they won't. It just depends on the interview. But I'd be good to go. I probably took too long because I'm over-explaining myself. I wouldn't explain myself this much to an interviewer. But, it's helpful for me to do this, helpful for me to teach people, helpful for me to, think through it myself. But anyway, I'd be at a good spot. So anyway, what you can do here, in addition that you couldn't do in a real interview, is you can actually submit it to Leetcode, and it will test it against all the other submissions on Leetcode to see where you stand up with them. And it'll also test it against a bunch of more test cases. So I'm going to do that. And it looks like it worked. It tested it against 102 test cases instead of those 5. So I know that this thing is working. It basically says I beat 82% of runtime for other people that ran this. Got to take that with a grain of salt. It changes every time you run it. But memory, you got to memory, I beat 88% supposedly. And I also can analyze the complexity here. So like I said, big O of N is the time complexity. That's the one I just described. So that's right according to Leetcode. And then the space complexity is also big over N, just like I said. So fortunately, I got that right. And so, yeah, look like I'm in a good spot with this. Looks like the interviewer probably would be okay with that. Yeah, so it's looking pretty good.